And the computer is sharing, so let me share my screen here. All right, so you should all be seeing. Oh, you should all be seeing the. Oh, wait. All right, the bright space environment. There we go. All right. All right, so the video is now recording. Very important. Let's go to the calendar. Take a look at where we are. Okay. For the course, take a look. We are at April 5th. That's today. More people. All right, so today is April 5th, and we're going to cover, as I said, security and firewalls. This will be the last lab, if you remember. I said this is the last homework assignment that you will get, but it should be a pretty easy one. You know, kind of fun. So we'll do this topic. I'll do some slides today that are on Brightspace. So I'll go over those. And we'll talk a little bit about the lab, which will be on Thursday. Okay. I remind you, next week, April 12, is exam number 2. Okay, please do not forget that. It'll be on Brightspace, so no coming to class on that day, right? So just take the exam from home. I'll be out of town. I'll monitor my email if you have any emergencies, but basically just expect the exam to open up. And then I'll come, you know, obviously we'll have class on Thursday, you know, just wrap up. I may do some scripting examples just to kind of wrap up. And then we'll have a lecture on the file system and a little bit of Docker on April 19th. Okay, and that's it. That's the end of the semester. After that, on April 21, I will want to see your projects just in person, right? Where you are on both Project A and Project B. Remember what those are? So Project A. Yep. Exactly. So great. So on April 21st, I just want to see it. Like, I'll sit with you guys just for a little while and you'll show me, and then you'll do the presentations on April 26th to the rest of the class. You need to come up here and do the presentation. You need to attend class. Please don't try to do this on Zoom, okay? So just attend class on that day. And then on the 28th, in case anyone misses the Tuesday, they can still shoot for the Thursday. Yeah. Yes, Project A and Project B, yes. There's no actual format, you know, just if you want to go back, it's first come, first serve basis. So whoever wants to go goes, and that way. And then we still have the April 28th, just in case you missed, but please, it's gotta be within those 2 days. Okay, and then don't forget the exam will be May 3rd. I believe it's at 2:45, and it'll be, you know, your final written exam, similar to the other exams, comprehensive. Okay, so that we complete the 3 exams. Each one I think is worth 10% of your grade, if I remember correctly. Does this make sense? So in particular, very important, don't forget April 12 is exam number 2. Yeah, so again, I want, you know, everyone should, you know, come to class, okay, and do your demos in class. You know, we are back in person, so everybody needs to be. Okay, any other questions? All right, so if there's no additional questions, then we've gone over the schedule. So now let's just jump into the topic, right? So this week, it's kind of security, if you will, firewalls in particular. Firewalls are a big topic, okay? There's a lot that we can talk about with firewalls, and at the same, it's a very simple topic because it's all the same thing, right? So firewalls are actually covered extensively in ITS 454, which is a network security course. So here, I'm only going to introduce firewalls a little bit from the perspective of Linux and Unix, okay? In particular, anyone know what the name of the Unix firewall is? What's the name? What's the name of the Windows firewall? Okay, Windows Defender. And then what's the name of the Unix firewall? No. It's actually called, the underlying thing is called Iep Tables. Yeah, that's interesting, but we're not actually going to use Iep Tables today. We're going to use an interface to Iep Tables, okay? So the underlying thing that we're using is Iep Tables in this week, but we're just not directly accessing it. The people from Unix and Linux decided that Iep Tables is very robust and very powerful and requires a little bit of a learning curve. And therefore, they just said, you know what, let's create something a little bit easier that's faster. And so they created something called UFW, right? Which literally stands for the uncomplicated firewall in Unix, right? So that's actually the name of it, UFW. So we will cover that one today. So let's go ahead. So everyone has signed in now. All right, so I'm going to then share the Brightspace environment, and we're going to navigate to 372 content. Right, and I think I've organized this already, so you can see we are currently here, right? So we finished SNMP, so that topic is now finished. And we are starting host-based firewalls. Really, we just have these two modules left. I kind of like going over this, scripts and things like that, and then the file system, obviously, Linux file system. We'll kind of formally go through it, but there won't be any homework assigned for it. I think, if anything, if you want, there can be a bonus homework. Yeah, I usually do one bonus homework per semester in case you missed an assignment, but you're on your own, so you got to solve it. But you should, all the documents are there, so you should be able to do it. But today, if you notice, the module is actually termed host-based firewalls. Okay, so this is really it. So host-based firewalls. So I have several files in here. Let's start, as I usually do, just with the lab document, just to kind of motivate what it is that you will have to do this Thursday. This is a very standard document, like the very standard documents that I prepared for 372. So it's got the same sequence of numbers with all the tasks that you have to do, basically. So what this one does is it walks you through using UFW on your virtual machine, right, on your Linux CVM 2004, and it'll show you, if UFW is not installed, how to install it, but it should be installed already. And then you'll basically run through some of the commands. It's very easy to add rules and remove rules. And basically, you guys know what a firewall is, obviously, right? It looks at a packet, right? And then it scans it, it's called, it sniffs it basically. And then it looks at the headers. So it breaks up the packet into individual headers. And then it compares the values to the rules that you have available. And then basically it decides whether it accepts the packet, lets it go through, or it's gonna drop it. Okay, so that's basically the idea here with this one, okay? So, and then, it's gonna walk you through various things like, things related to protocol, services, whether it's TCP, UDP, or ICMP, which are the common ones for firewalls in general. You know, also blocking by IP, etc. You'll then do a nice exercise with netcat or the NC, just to kind of play with tunnels and then rules and so on. Okay, and then finally, as usual, there will be a script that will be related to this, just to add some rules. So here you can see, write a Python script that can add 2 rules to the UFW firewall to block a specific IP address, okay, and a port number. The IP address and the port should be given via the command line. Okay, so that's basically what you will be doing, right? And don't forget, once you finish, remove all rules from the firewall, disable the firewall, given that that will affect the functionality of your VM. All right, so just, that's just kind of like a reminder. Don't forget to do that. But that will be, so that's the plan for today. This is literally your lab for this Thursday. Okay, so just be aware of that. So you just have to go through it basically. So now that we've motivated the assignment, let's go over the lecture slides. So I'm gonna do, so we have, don't forget to read these slides, centralization. So these slides basically are related to the managerial side of sysadmin. So always remember to read these, as there could be some questions on the exam, right, about them. So that, but I leave that to you as reading. And then we're just gonna focus today on this one, right? So the firewall slides, okay? So I'm gonna go ahead and download this one. Right? And then we're gonna open it. Right, so I probably share this one. All right, so you should all be seeing this. Everyone should be seeing it now. All right, so we're talking, as we talk about Unix. Now remember, this course, it's not a security course by any means, right? This is a Linux course, a sysadmin, where the system that you're administrating is Unix or Linux, right? So that's basically the goal. But as we talk about an operating system, obviously in Linux, security is a component, right, in general. So today I'll talk a little bit about security in general. The topic is actually, so sysadmin and security, but in particular, there's a lot of things that have to do with security. We're just going to focus mainly on firewalls, okay? And then our examples will be, as I said, the Linux firewall, which is Iep Tables. But we interact for this course, for the purposes of this course, we will interact with it using the interface to Iep Tables called UFW, which, like I said, is the uncomplicated firewall. All right, so, it's a funny thing about security, right? So are you paranoid enough about your systems, right? So that's kind of the idea. You have to, basically try to turn off services, etc., right? Or make it as restrictive as possible. That's kind of the, in a perfect world, you would be able to do that, but there's got to be a balance between security and functionality, right? And also cost. So that's really, so that kind of motivates that. So before we get into the technical things of security, of course, I'm not going to go through these since you guys take a course in disaster recovery, but just remember there's the whole disaster recovery issue. So you can just read through these slides, all the problems that can happen, right? And all the issues related to that. And then after that, we can start then focusing on security for your system, right? So before you start adding rules to your firewall, what do you need to do? You need to define basically what the risks are, the threats, right? And everything like that. So that's usually called the risk and control matrix, right? And you will identify what are the assets, right? And then you're going to identify what are the threats. And then you're going to identify what are the controls. Okay, so these are the things that drive how you're going to proceed with your security. This then will lead to defining what are called the security policies. Okay, and the security policies are nothing more than generic sets of rules or guidelines about your organization. So this is way before you start putting in technical things like rules in a firewall. Does that make sense? Like saying, oh, I'm going to drop SSH to all these machines, which it is, it's not allowed here, right? So that's a policy of the organization. They don't want you to SSH into these machines. But before they put in the Iep Tables rules or the firewall rules, there's a policy that governs that. They came up with that, and that's a generic idea, right? So that's basically the point here. So as I said, so you start with the RCM. The RCM stands for the risk and control matrix. So that just means risk management, right? So you go in there and you're going to go, risk is the relationship between assets, the vulnerabilities to those assets, and attackers who wish to access or modify those assets. Okay, so this kind of governs, what type of controls you're going to have in place. So risk is certainly the beginning of it. You look at all the assets that you have in the organization, and remember that assets don't just mean like physical things like servers and generators. It can also mean reputation. Okay, but that's really that's how the process begins, right? So identifying these assets, then identifying your security goals. Security goals are usually defined by the principles of information assurance, which you should remember from previous courses like 350 and 250, which are what? Confidentiality, integrity, availability, non-repudiation, authentication. You guys remember those? You do, right? So confidentiality, there's nobody reads your data, right? And so you can, this is just kind of a review. Then you have the threats. These are the possible attacks, people stealing your information with phishing attempts, which is, a big one. And then there's other things like malware, etc. So there's all the threats in place. The vulnerabilities, of course, what are the vulnerabilities in your organizations? So things like, insecure passwords, unused services and ports, right? And uneducated users, etc. So a lot of the things of sysadmin awareness, right? So, and then once you have identified all of those things, then that leads you to what? To the defense, right? And the defense is the controls, which are many, right? And as I said, in this course, we're going to focus just on firewalls, but there are many more. Usually there's defense types or terminology. So there's something like perimeter security, which is basically a firewall of the network, right? There's another term called defense in depth, which basically means that you secure your system by having your organization by having a system of multiple units. So in this case, a lot of these things work together, right? So you have the network firewall, and then there's the host firewall. So your lab, for instance, is only meant to be a host firewalls lab, which means only the firewalls that are on Unix itself, right? But there are, of course, firewalls in the network that prevent packets from reaching these machines as well. Intrusion detection systems are a type of firewall, but it has a different kind of objective, okay? And then you have other things, obviously, like system hardening or device hardening, which is basically turning off ports and services. Okay, so we've gone through just, the basic approach, right, to deal with or to start the security of your organization, which is basically the risk and control matrix. So you identify the assets, threats, risks, and then the controls that you put in place. Those should lead into policies, and then those policies, which are general descriptions, become actual policies on the individual physical devices, like a firewall. So here we have the defenses. So you can see here, there's basically a lot of them, for anything from spyware and virus scanners to patching the software in firewalls. So there's a lot of defenses, right? And as I said, this kind of summarized what I had said before. The risk and control matrix is usually a very good starting point whenever you're doing security analysis. Right, and then that leads to the security policies. You can see here, I have them listed. So there's many types. This is just meant to be like a non-extensive list of possible policies. So you have user level policies, what is acceptable use of your systems or logins, business level, like things like log retention. Okay, so those types of things. OS hardening policy, what you should do in relation to your systems, right? In general, you want to patch your networks and also turn off services. Right, and then there's physical security, of course, like locking doors and things like that. Checking logs, security auditing. So auditing is always a big one, right? So that basically means what is an audit? An audit is you have a list of things that are supposed to be in place, and then you want to go in there and check that they are actually in place, that somebody is responsible for them, right? And then they're running as expected. Right, and then there's a few other things here that this goes into. All right, so the main topic for today is the Linux host-based firewalls. So as I said, this is just one, as you can see, of many in defense in depth, right? In the defense in depth of your network. This is keyword here, host-based, which basically means this is different from, let's say, like what you're used to with a Cisco active security device, right? An ASA or something like that. Meraki's or whatever you've heard about firewalls currently. We are just, this is more focused on like, you all have a Windows computer and you're used to the firewall on your Windows computer, right? So that's basically the idea. So the underlying standard firewall for Linux is called the Iep Tables firewall. It's a very nice, very, very powerful, very powerful firewall that you have available. You basically insert rules, etc. But Iep Tables actually runs, you can run Iep Tables through something called the UFW interface. And this is basically a simpler way of just doing simple tasks in Iep Tables. So you can do things like blocking IPs, blocking ports, and dealing with incoming and outgoing traffic. Does that make sense? All right, so we're going to go to the whiteboard here for a sec. So let's go. All right, so we're going to talk a little bit about Iep Tables. So Iep Tables, oops, questions? All right, so Iep Tables, which I said is the Linux, underlying firewall. It's actually divided into tables, and then the tables are divided into chains. Okay, so that's the organization. So Iep Tables will have, for instance, several important tables, like the NAT table, which is the network address translation table. It's got the filter table, and it's got other tables that are important. Within the tables, you will have chains, right? And so, for instance, in Iep Tables, the filter table is divided into three main chains, which are input, output, and forward. Oops. Just use the convention of putting these as uppercase. So these are important because they have to do, they're very specific to the network traffic, right? So you have to, when you put a rule in Iep tables, you have to put it in one of these chains, right? To filter out traffic. So whenever you want to do the standard, I'm going to get a packet and I'm going to decide if I'm going to accept or drop the packet. You're going to put the rule within this, right? So within this chain. So for instance, let's think of the scenario here. So let's start with input. So for the input chain, that is only for packets where the final destination is the device itself. Do you guys see that? So you put in, let's say this is a firewall, sorry, this is a computer with 2 network cards, or it could be like a Raspberry Pi with 2 network cards, something, anything that would run Linux or Linux type OS, right? Let me change the color also. So if the packet, if the final destination of the packet is the device itself, then you should put the rule in the input chain. Do you see that? Now, the output chain, let's go over here. So output, right? So you have this. So output refers to packets that are leaving the machine, but originated from it. Okay, so that's gonna, so any packet that you generate from this machine and you wanna, what's a scenario where this is important? Let's say that there is a computer virus, right? So there's malware running on your computer. What will that malware try to do? Maybe that malware tries to steal data or establish a channel, like an SSH tunnel. Think of it like this. Imagine that this computer, and then there's another computer over here, which is the actual network firewall. And then here's the web or the internet, and then this is Russia, right? So some hackers hacked you, okay? And they put a malware on your computer. Now that you have some files here, right? And the malware steals the file information, creates a tunnel, and it's gonna, I'm gonna use a different color here. And it's now going to try, see that, to send the data out. So the output chain would be very important because, you look at packets that originated here, and then you could put in rules in here just to drop the packet. But the harder part is detecting that this is happening, right? So you may not know that there's malware in your computer. You may not know that. I mean, you didn't detect it. It's a stealthy type of malware. You don't know it's stealing your files. You don't know that it built an SSH tunnel. Now, remember, there's something called Firewall Evasion. I don't know if you guys have ever heard of Firewall Evasion. Have you guys heard of Firewall Evasion? So let's say, for instance, that you have on the firewall here, you have a rule that says that you block, it's just an example, that you block port 23, telnet, right? So you block it, right? So you have some rules in there, but that's all traffic that's coming in like this, right? In this direction that originates. But if there's malware on this computer, this traffic originated from the inside going out, and you may not have any packets whatsoever preventing that. Do you guys see that? So by just doing this, the attacker could build an SSH tunnel and evade the firewall, or they could just use an image tag and also access a server outside, right? So lots of things can happen. All right, so the output chain would be a good one to let's say block, right? So if you've detected that this traffic is going to Russia, then you could add a rule to block the traffic. Now so that's easy, and that's what the output chain would do, right? You could also send a rule to this firewall and also block it there. The harder question is, how would you know that there is malware sending information from your network to Russia? That's a different question, unrelated to the firewall. The firewall is just there to do what? Once you detected it, you could stop it. How would you stop it, do you think? On the firewall, what would you do? What could you do? Huh? Okay, yeah, I like that. What's the condition though? Perfect. You know what that's called? That's called geolocation. So the question that he said is exactly that. So you need to have in your network somewhere, you know, you tap in and you look at all the traffic that's going through, right? And then, as you said, you geolocate those packets going to Russia. And then once you've identified those IP addresses, you can immediately block those IP addresses on your firewall. Does that make sense? So you drop all traffic. So it's two problems, but the output chain would be very helpful for that, for adding the rules. And then this is called geolocation. As I said, this is actually a problem that we can explore. At least we'll talk about it. It's already in Brightspace, and it's pretty straightforward. You just like you've been doing Wireshark all semester, you can collect the PCAP files, and then there are basically, as you said, Python libraries where you can just run all the packets through it, and it's going to tell you what country they belong to. And so that's it. So it'll label them. Oh, this packet is going to Russia, and boom, you can drop that packet. You guys see that? All right. So that's an example of the output chain. Pay attention to this because these are probably going to be exams on the questions on the exam. So we have. Remember, the filter table has three chains: input, output, and forward. So input has to do with traffic going in. So I might ask questions like, you know, you're at computer A and you want to SSH into computer B. Add a rule on computer B that blocks that traffic. So then what chain do you use? Input, exactly. But then I could say for another one, this scenario like this, or some other different one, right? So I may just use this because I like it, but I may use a different one or slightly modified. Then you have to say output. Does that make sense? What I want you to understand is that it's, you know, the rules do go on different chains, right? The chains are also sequential. So what that means is that you have a chain, let's say the input, and you add a rule, and then another rule, and then another rule, and then another rule. What happens in IP tables is that this is very sequential. So the packet is like it's going through here, through here, through here until it matches. Once it matches, it's gonna do that, and it's not gonna do the rest. Do you see that? So position of your rules in the sequence is very important. What that means is, let's say that you want a rule that allows a specific, that blocks a specific type of traffic, right? So, but you might have another that blocks it, but you might have another one that allows it. So let's say that this one allows, and then you add your blocking one here. Well, the packet is going to meet this condition first, so it's going to be allowed through without ever hitting the block rule. Does that make sense? So that's why it means it's sequential. So what's the solution for this? If you want that this to take precedence, you have to move it before. So knowing the order of the rules is extremely important. Got it, guys? So that's an important issue to remember. And then going back to the filters, the third chain. So we've talked about this one, and now we're going to talk about forward. Forward is really interesting. It doesn't really apply much to our VM as we have it, given that our VM is usually just a one interface device, right? So it's connected to the network. And so the forward chain, is actually more related to devices that have two interfaces. You guys see that? So two interfaces. So this is, you know, and also that do routing. So a router, right? So, you know, you can create a router with Linux. You know, you all could right now create a router with Linux easily just by getting a Raspberry Pi. Raspberry Pi. They usually come with one network interface, but there's a USB. There's several USBs, so you can do USB to Ethernet, and then now you have basically a 2-network interface, at least in the hardware. Of course, you have to do some configurations on the command line to allow this to happen. Does that make sense? But you can easily create a router, and this will use Raspbian, which is Linux as well, so pretty much. Now, that's a good scenario to try out this idea, because the forward chain then says that the forward chain is necessary when you're dealing with packets that travel from one network interface to the other network interface. You guys see that? So it's got to be, for instance, a packet. So you got here, right? And you've got a packet that comes in here, right? And it travels through the other one, right? So these are packets that are being forwarded, basically. So when they are being forwarded, that's when the firewall forward chain comes in. You guys see that? So any traffic that it originated here, and it's going to end up here in your local network or something like that, but that it's passing from this to this has to be forwarded. All right, and so then you add the rules for the forward chain. Got it? Yeah. All right, and that's basically it. So that's an important idea about Iep tables itself. Now the commands, as I said, we're not going to really get into Iep tables, just the UFW firewall. But just for information, if you go to the terminal, right, you go to the terminal, the commands usually start with Iep tables, right? And then you're going to do, let's say you're adding a rule, so you're going to do -I or -add, right? Adds at the end, and then I inserts where you specify. So for instance, let's say that you're adding to the forward chain, then you would say 3. And what that means is if you have a chain, like this, right, it'll just insert it at position 3, and then it moves everything down. So it kind of squeezes it in there. And then after that, you just basically specify what you want. So for instance, you would say TCP, right? And then you would say destination port 22, right? And then you might say destination host, and then 205.215.116.11. You guys see that? So this rule basically only has to do with packets that are being forwarded. So what I want you to understand is, if you have this device, but you have a packet that originated out here, but ends up in the machine, this rule won't do anything. It'll never pass through it, right? Because that depends on the input chain. So this will be an input chain related rule. Now, for the forward chain, you would need traffic, as I said, that comes, let's say, from the internet, hits here, passes to the other interface, and out, right? In that case, now, yes, the forward chain will be activated. It'll be rule 3. And what type of what is the behavior of this rule, do you think? Oh, and I forgot one thing, right? I forgot drop. Sorry. What that means is drop the packet itself. So let me change the color of this. -drop. So what do you think this rule will do? Yes. So port 22 is SSH, right? So basically the TCP packets going to port 22 only, and for that specific host will be dropped. Exactly. And this is basically the syntax of Iep tables. So pretty straightforward. Other things that you can, and obviously there's more rules to it, but it doesn't kind of make sense to go over all of those, since we won't be doing a lab for them in this class. The only other thing I'll talk about is that there are other, where is that? There are other tables, such as the NAT table in Iep Tables. And those actually have nice, interesting applications that you can play with. So all right, so let's go over here. All right, so we're going to talk a little bit about the NAT table. And I'm going to just give you a problem that's kind of fun and interesting, where we use NAT and filter. Have you guys heard of the term port forwarding? Have you guys heard of this term? Have you ever implemented this? What, a couple of times? So what is it? So for video games, yeah, good. You've done, so you're all gamers, right? So you gave away your hobby just now. All right, yeah. So how do you implement this? How did you do it? Yep. And it did it, right? It did it. So it's just a GUI that does it. Probably if that's that firmware, I'm betting is using some variant of Iep Tables, right? And so how is it doing it in the background, right? So that might be the question. Well, it's actually straightforward. So again, if you had, something like a Raspberry, as I said, you could play with this. It involves the two tables, NAT and filter. So let's imagine an imaginary Raspberry Pi, right? So we all familiar with that, costs like $20. It's got Raspbian or something like that. It's Unix. It's got the two network interfaces already. We configured it, and we want to do port forwarding, right? So we've got over here your whatever machine you're trying to reach, right? So let's say this is your machine, and it's going to be, I don't know, 10.0.1.7, right? Out here, this is 205.215.117.20, something like that, right? And this, might be the web or something of that nature. So how do you implement this port forwarding actually in Iep Tables? Well, it's just two rules. It's not even that complex of a thing to do, but it does involve two rules. So rule 1, and then let's say rule 2. So one, you already know what it is, right? You might imagine we said that any packet that goes from one interface to the other interface must be governed by the forward chain. Do you guys see that? By definition, or by design, I should say, not definition, by design, things from the outside are not allowed. And also, things going from one network interface to the other are restricted, right? So you have then, first of all, your goal in port forwarding is going to be that you're a remote worker of some kind. So let's say, you have a laptop, let's say over here. You're trying to reach this computer over here, right? So I'm going to use another color here, like blue. So you're coming like all the way. That's your goal. That's your objective. To be able to achieve that, you need to do two things. You need to grant permission for packets to go through this barrier. That's the forward chain. But also you need, when a packet hits here, you have to, as you said, open a port. Not only open a port, but you have to map that port to where it should go. So what that means is you need to establish a route, purple. You have to establish a route that says, you know what, if you send me something here, I'm going to forward it to 10.0.1.7. On port, let's say, I don't know your gaming ports, but let's say, what are your gaming ports? All right, 7. It's just a number, right? But out here, we need to open a specific port, whichever one you want, on the router itself. Do you guys see that? Does this make sense? And so that's the idea, right? So you need two rules. The one rule is the forward rule. So it's going to be IP tables forward. The type of packet that is going to go through here, maybe it's like a TCP packet with destination 10017 on port 777, right? So I'm just going to write TCP here, ... And then you're going to say -accept. Do you guys see that? So you're going to allow that packet on the forward chain. Does this make sense? But there's still the other, and this happened on the filter table, right? So this happened on the filter table on the forward chain. However, you still need to open a port and to tell it that whenever you receive a packet on this port, what to do, which is basically to redirect it to that machine. That's where the NAT table comes in. The NAT table actually has several chains, including one called pre-routing. So pre-routing. Do you see that? That's the chain that you're going to use. So in this case, then you would say IP tables pre-routing, and then you're going to specify all the parameters. So what do you need to define? You need to define the interface. So let's say that this is ETH0, and then this is ETH1. So then you would say -I ETH1. You see that? And you specify that on that interface, then you're going to say -port 4000. So that means that that's the port. And then you're going to specify what should happen, right? And that's usually the DNAT. And then you're going to say send it to 10.0.1.7 at port 7777. Do you guys see that? That's it. It literally works as simple as that. Okay, so what you have done, the port forwarding that you have done, obviously when you buy a product, right, they're going to give you some GUI and then you just have a setting. But underneath, if you're doing this in Linux, the logic would be to use IP tables. So I said one is the one that does the mapping to forward the packet, but still you need a second rule because the packet will be going from one interface to the other. So that's the forward chain. And that's kind of, that's the basic logic of IP tables. So I think these two provide a good description of it. Are there any questions about any of this? Any thoughts? Yeah, go ahead.
From my experience in port forwarding, you have to do this for UDP.
It could be, yeah. So it depends on the type of packet. So if your game is UDP, and then there's TCP packets involved, yes, definitely. I mean, this is very specific, right, to whatever packet is going to go through there. So you definitely need to have them in there. Anything else? Now, you don't want to do one rule that says allow all, right, on the forward. That's probably not a recommended thing. You would probably want to do rules that are just specific. So actually, you brought up a thing because you could say allow everything. Allow IP, right? What if you just say allow IP? It's going to allow through, pretty much all packets are IP, right? So you have that issue. So you want to be a little bit more restrictive based on the service, probably even as far as port numbers and things like that. Got it? All right, and so that is IP tables. In general, as I said, in this lab, you will actually be practicing with the UFW, which will make the rules even simpler than this. You will not be using the command IP tables. You will be using the command UFW, as we will see in a short while. And then we'll do some Python scripting also, just to kind of get a feel for so when I turn on the virtual machine. But this is just a big picture overview. For the exam, just keep in mind, I might ask questions like this, Yeah, so what is IP tables? Well, basically, obviously, tables for IP control, right? And then there's several tables, such as the NAT table, filter tables. Tables are made up of chains. And then the chains are very important, and they govern the direction that you're going in, right? So they govern, whether it's input, output, or forward. And then, we went over some scenarios of input, output, and forward. And then also we looked briefly at how the rules are actually written with the Iep tables example. You can see that it's a little bit more verbose, if you will. Writing them in Iep tables, UFW will be a little bit more simpler to write. And then also I gave you a scenario of port forwarding just to kind of illustrate in more detail how Iep tables can use multiple tables to accomplish things. There are other tables where you can have a packet that's going out, but before it goes out, it goes through that chain, and the packet will be modified slightly as well before it finally goes out into the network. But we're not going to look at that. If there's pre-routing, there could be post-routing and those kinds of things, right? So, but yeah, so that's the general idea of Iep tables. So let's go back to the slides and just kind of continue our discussion. So we talked about Iep tables here. You can see that I covered Iep tables. Then there's UFW, which, as I said, is just an interface to Iep tables. It's not a second firewall. And this one, it's even simpler. You don't have to worry here so much about putting things in the right chain, right? So in here, you think of things a little bit differently. Also, keep in mind that the Linux VM that you're using, 2004, think of it as just a device with one interface, right? So in that case, which of the three chains would be the one that you are mostly using? Input. Perfect. Input, because everything really is going to that device, right? So that's generally the thing that you're going to be doing. Be careful with the rules that you implement in your device. You could literally block yourself, right? And think about the things that you can do with the machine, right? So, if you said something like block all IP traffic, you're going to block all IP traffic, huh? You could, yeah. That's what I'm saying. So you have to be, especially if it's input traffic and you're trying to SSH into the devices, for instance, which is one of the exercises, you may actually block your SSH. And just think about these things, because you may think that it doesn't work or that you're not doing it right. And it may just be that you added a rule that's preventing it, okay? Yeah, just think that the rules actually do stop things, right? So that's one thing to consider. All right, generally speaking now, I've talked about Linux Iep tables. Now, as part of the course, we're just going to talk a little bit about firewalls in general, so more broader topic outside of just the host. So you can see here we have the standard network, or you have the internal network. So this is your company, where you have your payroll servers and whatever it is that you have in the company that is of importance to you, right? And then usually firewalls are placed, to control your traffic. So you have, the main firewall, and then you have a router here that basically is the one that connects to the internet, right? So then if you have web servers that need to be accessed by the people from the outside, like customers, right? You're going to put these outside of the firewall, not inside. Do you guys see that? Do you guys know what this area is sometimes called? This segment of the network. So think about what I'm doing here, right? So I have like that, right? Where I have, this is the internet. So obviously where dangerous people live, right? Huh? Not a pipeline, no. This is a router. This is probably your ISP router, right? But you can have some rules in here. This is the firewall that prevents access to the internal network. But let's say that you have a web business, right? And you're not in the cloud, you just have your own like servers and things. So you put these servers in the segment, which is not here, right? Because you definitely don't want to do port forwarding here, is what I'm saying. You definitely don't want to do that for your company. So you just put your servers in this switch, and you pretend that this router, this router is less restrictive. It does allow some traffic, like port 80 traffic, right? So do you guys know what this segment? Not the intranet would be the inside of the company. So like if I had my own Wikipedia, that's the intranet, right? And only people inside can access it. You guys know what this one is called? Yeah, that's right. That's the DMZ. That's the DMZ area, the demilitarized zone. Okay, and that's just the area for putting in things that can be accessed from the outside. There can still be some restriction on the router, just less so. Does that make sense? Or no?
Yeah. It's like the actual
Yeah. So yeah. So it has to do with these things called domains of trust. So we'll see that in a second. But yeah. All right. So I don't know how to erase with this on the slides. All right. Yeah. So what the need for firewalls, you guys know, I'm not even going to say this. You know what it's for, right? So it's a network device that blocks the traffic. All right. So there's the firewall characteristics, the design goals. All traffic from inside to outside must pass through the traffic. Only authorized traffic as defined by the local security policy will be allowed to pass. But usually all traffic from the inside is allowed out in general, right? However, traffic coming from originating from the outside to the inside, it will not be allowed. Okay. Now, the techniques used by firewalls to control access and enforce the site security policy include service control, which basically just means, look, if you remember the second lab we did services, right? So just blocking by port number. The direction is also important, right? So if the packet is going or what the direction is. Users or the behavior, these are more advanced ones, like denial of service attacks. Am I getting so many packets per second or whatever? You might trigger also a rule. Remember that firewalls actually drop packets in real time, right? So that means they have to be fast, okay? Because they have to be fast, they can't actually look at everything in the packet header. So what is a packet made of, right? So a packet is made of different headers. You guys know what the headers are? What's the first one? The Ethernet header, right? Like the hardware level where the MAC address would be and all those kinds of things, right? What's the next one? Header. Protocol. The protocol is a parameter that would be in there, but it's called the IP header, right? IP header. And then what about after? What would be next? What's the next header? Yes, exactly. So it would be either TCP, UDP, could also be ICMP. What's ICMP? Ping packets, right? And then TCP are you guys know these, the three-way handshake, right? And then UDP ones are the ones that don't have established handshakes. Now, I drew this because after that, you can have payload. You see that? Payload is a lot of information, and usually firewalls don't analyze payload because that would put out too much work on the resource of that firewall, and then it would slow down your network, right? So usually then, because the packets need to be really fast so that you can actually work in a fast way, right? Basically, I don't know, I can't change the color. Yeah, basically, firewalls will look until then. Okay, and so that's what this slide says. A packet filtering firewall applies rules On each incoming and outgoing IP packet, typically a list of rules based on matches in the IP or TCP headers. So here, right? So it's just looking for things like IP address, protocol, as you said, port numbers, which are the services, flags, SYN flag, ACK flag, that kind of thing. And then it forwards or discards the packet based on rules matching. So basically here, source IP, destination IP, source and destination, transport level address, IP protocol, interfaces, etc. Okay. All right. Okay, hold on. There we go. All right, so advantages is simplicity, typically transparent to users. Weaknesses, it cannot prevent attacks that employ application-specific vulnerabilities, right? More advanced ones. And then stateful inspection firewalls are just a little bit more advanced. Tightens rules for TCP traffic by creating a directory of outbound TCP connections. There's an entry for each currently established connection, and packet filter allows incoming traffic to high-numbered ports only for those packets that fit the profile of one of the entries in the directory. So basically, it just keeps track of the traffic here. You can see there's like a table of established connections on the firewall. Okay, so that's basically the idea. Now, what we're talking about in this week is the host-based firewall. So used to secure an individual host. You understand this? So that's just your own devices. Available in operating systems or can be provided as an add-on package. So you guys, Windows, right? You used to install a firewall, right? Which one was it that everyone used to install on Windows? Like, forget the name. Now there's a default one, right, on Windows, but before everyone would install, some kind of a firewall. And in Linux, as I said, you get the UFW firewall. Huh? Isn't Norton antivirus? Was it a fire? They do have a firewall. Yeah. So McAfee was definitely just antivirus and malware itself. So it was very annoying. But I remember there was one open source one that was famous for a while, but it escapes me right now. Something blast or something like that. Auto blast. I don't know. I can't remember. Maybe somebody said it here. Yeah, you're left. All right. Anyway, yeah. So the idea is to filter and restrict packet flows. Okay. So the advantages, filtering rules can be tailored to the host itself, right? So that's good because it's only rules that pertain to that device. Whereas if you have a network firewall, it's going to be kind of a catch-all, but some traffic may need to be allowed through, right? Because it's outside in the perimeter. Protection is provided independent of topology, so it's just specific to the network. And it provides an additional layer of protection so that you have the network firewall and then you have the individual firewalls as well. Okay. Now we're going to talk, I believe, about domains of trust here. Nope, not yet. Where are those? Oh, here they are. Okay, so. All right, so we're just going to go through this really quick. Firewall configuration in the network. So you would have basically what we said before. You break up into segments, which are what you would call domains of trust. You see that? These are domains of trust in the sense that you're going to assign to each domain what? A level of trust. So looking at this diagram, how would you rank these in terms of domains of trust? Let's say that 0 is less trusted. And then 100 is more trusted. So that's how you would segment this out. So the segments are basically whenever you have one of these choke points, right? Like here you have a firewall, another firewall. These are switches, right? And then these are computers. Look at what the definition of the computers are. So basically, if we have these three, how would you assign domain of trust by adding a value, a rank between 0 and 100. So how would you assign it? Not to the, you could do it at the computer level, but just do it at the segment level, because like this is a firewall, so this will be rules will be there. This is a firewall, rules will be there, right? So how would you assign that? Yeah, domains of trust. You have a question? Oh, yeah. Switches to what? I mean, you could create VLANs and things like that, but they're not meant to be ACL devices that drop packets. So then I just mean these three, right? So this is a domain of trust, this is a domain of trust, this is a domain of trust. So, okay. Why 0? And that means less trusted, right? Okay. What about the following ones? Yeah. Okay. Okay, a low number, let's say like 30, 0.30, I mean. Oops. And then what about the last one? The most trusted, right? So that's how it should be. So that's basically here, this is the internal network. So you have your workstations, your data center, etc. So nothing should be allowed that initiated from the outside. However, as you said, some users need to go through this to get to the web server or the email server, etc. So this firewall will have filtering, will have rules, but just fewer rules. You guys see that? So it will have definitely fewer. And so that's what domains of trust basically means over here. Okay. All right. So let's see where we are. So the next part is getting into rules. Okay. So we'll talk about that a little later. This is a good example of the domain of trust, right? So you can see how the trust is increasing in that direction. Okay, so as you said, this is the internet, so it's not trusted. Public servers, right? So this is the public server trust domain. This is the internet trust domain, wide area network trust domain, basic user trust domain, and then the more sensitive, like your finance or payroll sections, right? So basically, based on this organization, you would proceed then to segment out your network, because you've identified all of these common domains of trust. And then now you can start building the infrastructure that you want to have. So, and this is 3-domain security design, where you have, if you look over here, one router, right? Then you have a firewall. And so this now is your inside network, but this has basically another router here, segmenting off things like the user network or this one, which would be the more secure needs to be. Okay, so that's called domains of trust. It's just a separation of your segments, usually done by some kind of a device like a router or a firewall, and usually the firewall is just a more secure one of the devices. All right, so one last thing, and then we'll do a little bit of the scripting part. So this is just a diagram. It's a very similar diagram to this one, basically, okay? So as far as security is concerned, we also have the concept of VPN, right? So what is VPN? Virtual private network. So how does it work in the context of this? Here, let's look at the domains of trust, right? We have, this is the internal network. This is the internet. And then this is the DMC, you can see, right? So we had looked at this before. So where does the VPN fit here in this whole network? And how do you use it? Sorry? Let's say that you have a remote worker here, right? You have a remote worker. The remote worker is using a laptop working from the airport. and they need to access a server in the inside network. So they've got like a spreadsheet that they need or something like that, right? But that's in the internal network. So how do they solve that problem of getting that? Should you, what would you do? We could do port forwarding, but that's probably not very secure, right? VPN. How do we do VPN? How does it fit in? What is, I mean, I know you guys know what VPN is, but how does it fit into this? Lenny? Okay, sure. So what you're saying is the remote worker is at the airport. The remote worker has what is called a VPN client, right? A little bit of software. And when they turn that on, what you said is now that it's going to be like they're inside this network and they have access to the server, right? But where's the VPN here? Where does it live? It's a server, obviously, right? So it's a VPN server of some kind. Yeah, go ahead. Sure, but so give me a scenario. Just I want you to think about this.
So let's say I want to connect to a VPN because I want to watch a show that is banned in America. So I connect to that VPN. It makes Netflix think that my IP address is coming from, let's say, England, and their server is giving me an IP address to use in their network. Then my computer connects to their network, then connects to Netflix
Right.
instead.
Yes.
Mine.
And that's correct. That's totally correct. But what about here? Like, where would you put your VPN here? On the router? Okay, so you would put some software here, right, on the router. So you would connect. So think about it. I want you to think about it. So you connect to this one, and then now this changes your IPs and everything. But how are you going to get through the firewall? From the outside, because you're initiating from the firewall, from the outside. Do you see that? What's the point that's stopping you in this whole thing? The firewall, right? This is where you can't really cross. So I think what you said makes sense, except instead of putting it here, put it here in the firewall itself. So actually firewalls are also, have also built-in VPN. See that? So then now what you do is because you'll be able, if you ping, you should be able to ping up until here, which means you can get to the outside interface of the firewall. And so now your IP client, your VPN client also, instead of pinging, will just reach this, knock on the door on a specific port number, and the VPN services here, the rules, will allow you through. And we'll do a type of port forwarding, but more sophisticated, obviously, and with encryption. It's through the firewall, yes. And actually, now you could have a VPN server outside, right? You could have it like a direct VPN server here, but usually it just makes more sense to have it in the firewall itself. Good question. So let's go to the whiteboard and let's see how you would implement this fully. So you have a login, right? That's the thing. You're going to have a couple of logins. So let's go over here and let's think about it. So I'm going to draw the ASA is the firewall, let's say, right? And there's a switch here, right? These are switches. And then this was the router. And then this is another, that's a good idea. I'm also going to change color. All right, so the remote worker is here. This is the web. They're at home on their laptop, and they have a VPN client, okay? On here, there is software, firmware actually, on the ASA itself that does the VPN software, but the authentic, and everything is encrypted, right? So everything is going to be encrypted through like SSL, right? Which is public and private key encryption. So the VPN client handles that, right? It'll generate your keys. The keys are here, and you'll do that whole SSL transaction. So there's that. But you also need to authenticate the user. Now, usually the way that works is you're going to have something like a domain controller. Oops. So basically like a Windows Server, right? So Windows Server will be your domain controller inside the network. What does this domain controller need to have? It needs to have two services, something called Radius, and what's the other one? Active Directory, right? So Active Directory is where you can add the user with password. You guys see that? Does this make sense? And then the Radius service, let's say, is going to be more like a network level authentication. So what the Radius server would issue is, let's call it a token. You see that? Yeah. And so what needs to happen now is that when you open your VPN client over here, VPN client will generate your public and private keys. And obviously this has its public and private keys. And then you're going to be able to do that whole exchange, right? Like you do every day with e-commerce, right? And then you're going to exchange, that's for the exchange of the symmetric key, right? And then you use some algorithm like AES or something like that. However, there's got to be in your VPN client also the token, and it's got to have the username and password. So when you send your transmission to this, so let's say you knock on the door of the VPN, first it looks at the token, right? And it's going, change color again. It's going to basically send it to the domain controller, to the Radius service running on it. Both of these services can be on the same device. It's going to check the authentication of the token. That's good. Checks out. That's kind of a network level authentication. And then once you pass that, then it's going to ask you for the username and password. And that also goes through the domain controller, but it goes to the Active Directory service, where that account and that password must exist. And then you are authenticated. Do you see that? So those are all the security mechanisms. And I mentioned VPN only because it's a service usually in the firewall, so it makes sense to know a little bit about it. Configuring this through Iep tables would be a lot more complex than the two port forwarding rules that I gave you. There's a lot that goes into that in terms of like rules, so we're not gonna look into that. But yeah. Is this clear enough, guys? Are there any questions? All right, so let's go. All right, so hopefully that answers that question. So now let's go back to these slides here. So we talked about these rules and the organization. Okay. So we talked about all this. Yeah, we talked about VPN, so I kind of jumped ahead. All right. Yeah, so that's good enough. So I think if you want to read more about the slides, but I think we've covered all the basics. All right, so that kind of concludes just the theory or the slides. And now we can go ahead and just look at the lab again. So we can go back to the lab just now that we have a good sense, right, of the lecture, and just see what the assignment is for this week. So remember, this Thursday, you will be working on a lab assignment, which is your last homework assignment, okay? So let me go to table of contents. All right, so this is the document. Okay, so basically you will go through all these commands, just setting up the UFW. You can see that it's a lot easier to just set a rule in UFW than IP tables. And as I said, literally it's in the name, right? The uncomplicated firewall. So basically the idea is UFW allow 22 or deny 22, right? So these are kind of commands you can assume going towards the input chain even, right? So they're not forward level rules basically. All right, so you'll go through this. It shows you how to, basically allow or not allow. So you can see here sudo UFW deny 22. So you can experiment with that. Sudo UFW status, right, to see the rules that you have currently in place. Now, when you want to turn off the firewall, you do sudo UFW disable. I believe by default your firewalls are disabled on 2004. I believe. If you want to enable the firewall, sudo UFW enable. Okay. Sudo UFW status verbose just gives you more information. This example here talks about ICMP or pinging, right? So you can also go to, there's a folder associated with your UFW program in the etc folder, okay? And so there you can go in and open, in the etc UFW, you can open several files, including before.rules. And in here, you have some built-in rules that you have in there, so you can change them basically, right? So change the accept here, for instance, to drop. So by default, the VM will accept pings, but if you change the word accept to drop, then it'll drop them basically. And you can see this is starting to look a little bit more like the IP tables rules that we were talking about, right? But you don't have to implement them like this in the UFW prompt. Okay, and then here you have examples of blocking an IP address. So you can see you have UFW deny from IP. Notice that the word from implies the direction, right? So that's an important thing about the packet. Or you can do UFW allow from IP, okay? So these are basically the rules. And then here, this just gives you an example of using a tool called Netcat. It's just kind of a nice thing, allows you to set up tunnels. So you can play with that one as well. And, basically use UFW with relation to it just to kind of see how it works. Okay, so you'll set up some rules related to that scenario. And then finally, we are ready, I think, in the time that we have left, just to go over our Python script, just so that you can implement it on Thursday. So the Python script, so let me go ahead and start the virtual machine. We're going to write it up, and then you guys can just run it Thursday. So I need to start the VM. All right, so we're ready. Go ahead. Again. Oh, and I need to share this with everyone. Right, so everyone should be seeing the virtual machine now, right? But before that, let's go to the Word document just so that we know the problem. There we go. So the scripting problem is write a Python script that can add 2 rules to the UFW firewall to block a specific IP address and a port. The IP address and the port should be given via the command line. Okay, so basically all you have to do is you have to create a rule for that. I'm just going to give you the basic pipeline, but at this point in the semester, this should be trivial for you guys, right? To write this kind of a script. So, but let's go ahead and do that. So I'm gonna, I need to share. Go to the virtual machine. I'm gonna go to the desktop. It's gonna be ITS 372. And yeah, so in here we can create a new file. All right, so let's go ahead. We're gonna call it, add UFW rules.py. All right, and we'll need a couple of libraries. So we'll do import sys import subprocess import OS. And there's a couple of ways in which you can solve this, obviously. So I leave it to you guys, however you want to do it. You need to read the port number from the terminal. So to interact with the terminal, when you run the command and then provide some input, you can use the sys module and then just do sys argv, and then you just indicate where you want to have things. So usually by default, 0 is the command itself. So like your script, if you did Python, my script, py, that's 0. And then space, a value, that's 1, space, a value, that's 2. Okay, so just keep that in mind. So then this would be 1, because you don't want 0 would be the command itself. And then you're going to repeat that for the IP, and that's going to be also sys.argv, but this time the number 2. Does that make sense? All right. All right, so you have these from the terminal now, and now you can just go ahead and add the rules. So you can use the OS or subprocess. So in this case, I'm just using os.system. And in here, I'm going to plug in the rule that I want. So in this case, I'm going to invoke the UFW firewall. So UFW, and what did we say? We're going to deny? I forget. So let's say it's deny. So UFW deny. And then you can just concatenate whatever it is you want to do. So deny port number. And then you can do os.system. UFW, yeah, deny, I guess. Deny from, and you concatenate IP address. Does it make sense? That's it. Right, so it should be pretty straightforward. Now you want to make sure that the rule was added into the system, like a confirmation. So you probably should do print, do a print first and just say something like showing rules, ... And then now run another command, os.system. But this time around, you run the command UFW, and then just do something like status verbose. And then you can take a look as a confirmation that those two rules were added. Still, you should test this, so whenever you do these tests on the lab, run the thing without the rule, show that it works, then add the rule, and now show that it was blocked. Okay? You guys see that? And that's it. This should work. But obviously, this is what you have to test on your lab on Thursday. Okay, so I'm giving you the code, make it work. All right, and create some test scenarios where you test this with different IPs, different port numbers, and so on. Obviously, do the script after you've gone through the whole lab so that the whole lab will give you some intuition as to using UFW. This should be a very easy lab. As you can see, this assignment is pretty straightforward, so easy points. It is your last homework assignment. So I'm going to go ahead now, save this, and I'm going to create the Dropbox for it. So let's go ahead. I'm not hearing any questions about the script, so let's go to Brightspace, share the screen. All right. So everyone should be seeing Brightspace. So I'm going to go to host-based firewalls. And in here, I'm going to add the link. So new assignment, last homework. Homework, UFW firewall. This will be due on the 14th, 10 p.m. It'll open now, and it'll stay open until the 16th. So let's say complete the attached Word document related to the Linux UFW firewall. Clear enough? All right, so save and close. All right, and that's basically it for today. So that concludes the discussion. So we went over, as I said, IP tables and UFW. Your lab is pretty simple for Thursday. Read through the slides again if you have any questions. Otherwise, I'm going to stop the recording here.